So my name's Keith Moon. I'm going to talk today about machine learning for iOS developers. So, as I said, my name's Keith Moon. I've been developing iOS apps for quite a while, since about 2010. Worked with a bunch of companies, including BBC News, and I'm currently with Just Eat. And I'm working on the book at the moment for Swift Free. That should be out in the next few months. Just a little bit about the company that I'm working with at the moment, Just Eat. We help people find great food locally, so takeaways. We provide the ability for you to get food quickly and easily. And we're on the web, iOS, Android, tvOS, and Amazon Echo, which is quite a new thing. And we operate in a bunch of different countries. Not Belarus yet, but hopefully that will change, including Canada and New Zealand. Okay, so firstly, what this talk isn't. Okay, so I'm not a machine learning expert, and I'm not a Python expert, so there's going to be a little bit of Python in this talk, because that is one of the primary languages people use for machine learning. And I'm not a maths expert either. There's a lot of maths involved in machine learning. Not really my interest, not really interested in the maths. I'm more interested in what we can actually do with machine learning, how we can use it to add features to our apps. So it's not going to be a huge deep dive into machine learning. We're going to look at the concepts of machine learning and how the technology comes together to answer questions. Okay, so now we've talked about what talk isn't. Let's find out what talk is about. So we're going to take a look at machine learning from an iOS developer's perspective, how you can use machine learning. We're going to do a high-level overview of machine learning, what's involved, and how you go about implementing it. And we're going to look at what questions we can answer using machine learning and what things we can do. And then finally, we're going to look at how we can actually use machine learning in our apps, what features we can enable using it. And then very quickly, we're just going to take a quick look at the current state of tools for machine learning and what's available to us, and what may hold, the future may hold for using machine learning. So before we move on, let's kind of get let's clarify some terms, because we hear machine learning used a lot. We hear neural networks and deep learning and artificial intelligence, and all of these terms are often used sort of interchangeably when a company's releasing a new product which features artificial intelligence. What does that really mean? So let's take artificial intelligence first. Artificial intelligence is a very broad term that describes the research for trying to help computers do things that typically humans have been very good at doing, but computers haven't. So things like pattern recognition and natural language processing. Humans are very good at doing it, computers not so much. So artificial intelligence is a broad term to cover all of these sorts of things. Now, machine learning it fits within artificial intelligence. It's a technique for helping computers to learn from previous experience. And again, it's quite a broad term, but it generally means research into helping computers learn from experience. Now, within machine learning, one of the techniques for accomplishing this is often to use neural networks. Now, neural networks are a tool that can be used both in machine learning and outside, and we're going to take a look at some examples today using neural networks. Now, deep learning is an area of research within machine learning that uses neural networks and produces deeply layered neural networks to help answer the questions that we're trying to answer. So it's a type of machine learning. Okay, so now we've got a kind of idea of all the concepts. Let's take a look at some of the things you can use machine learning for. Some examples of where machine learning is being used today. So you've got apps like Masquerade and Snapchat, where they're using machine learning to identify, and neural networks to identify faces, and using the fact that they can identify faces and facial features to then overlay 3D filters and 3D avatars on top of your real face. And then we've got voice interfaces like Siri, Google Home, and Amazon Echo. They are using machine learning to identify what is being said and turn that into actionable onward journeys. And then in the future, machine learning is going to be used for driverless cars from Tesla, Google, and Uber at the moment. They're all working on this technology, and that uses deep neural networks and machine learning at its heart as well. Okay, so very quickly, what kind of things might we be using machine learning for within our apps? These are some of the use cases for machine learning that you see today. Things like spam, handwriting recognition, text prediction, like in messages in iOS, as you're typing, it suggests the next word that might be coming. That's using machine learning. Sentiment analysis, pulling out meaning from text. So analyzing tweets and deciding, is this a positive tweet about a company or is it a negative tweet about a company? Image style transfer, which is it's quite an interesting thing recently, where you take two photos and take the style of one and apply it to the other. Now, of these use cases that we have here, a bunch of them fall into a sort of specific category of machine learning, and they're sort of classification problems. So for these problems, essentially, you have a bunch of data, you want to put that data into certain buckets, into a finite number of buckets. So handwriting recognition. For a specific character, we want to know, is that an A, or is that a 0, or is it a 7? So we're putting each character into a certain bucket so that we can then do some, so that we can then understand the text. Same with sentiment analysis. We want to know to what extent does this fall into the happy bucket, this piece of text. And with spam, we've either got an email is either spam or not spam, so it's still a classification problem. And so the classification problems is something we're going to work through today as an example, and we're going to see how we can use machine learning to solve these problems. Okay, so very broad level, this is the setup we have when we're trying to solve a problem using machine learning. We have a set of training input, which is a whole load of data where we have the data and we also have the bucket or the category that it should go in. We then feed that into a neural network. The neural network learns how these pieces of data fit into these buckets. And once the neural network becomes trained, you then have, once the network becomes trained by feeding this data in, understanding what buckets it ends up in, doing that over and over again until the network has learned these patterns, learned how to turn this input data into these categories. You then have a trained neural network, and now you can take unknown data, data where you don't know what category is going to be in, feed it into the neural network, and get the right results out the other end. So that's the broad pattern. That's the way we answer these questions. So let's take a look at what this neural network is in more depth, get an understanding for what this means to train this neural network. How is that accomplished? So a neural network is, like any other network, it's a set of nodes and connections. And these nodes are organized into layers. We have an input layer, which receives the information from the input data. And then we have a set of hidden layers. And then at the end, we have an output layer, which corresponds to each of our buckets, each of our categories that we want to put this data in. Now, the hidden layers are called hidden simply because they're not the input and they're not the output. They're in the middle. They're hidden from the outside world. And in these layers, and these layers are often completely interconnected, as you can see. So all of the nodes from the previous layer connect to all of the nodes in the next layer. And in these hidden layers, the data passes from the input to the output through these layers, and the values that these layers have is what is the training of the neural network. And we're going to look a bit further into what that means. So let's dive into just a really simplified example. Okay, so here we have 3 nodes that are feeding into one output node. Okay, so what does it mean to train this neural network? What we have here is we have the 3 values are making their way through the neural network. And these are numerical values. And the connections that they have to the next layer down, the connections they have to the output layer, are given weights. And those weights are used in the calculation of what this output layer is going to be. And this output node also has a bias. And these values together is what determines what the next node is going to have as its value for any subsequent nodes, any subsequent layers that come on. So, how this value is calculated is you multiply the previous layers, the previous node's value with the weight for that connection, and you sum over all of the connections into this next node, and then you add the bias, and then you apply an activation function to that. And that is simply a function which determines to what extent these values affect whether the node is on or off, so 1 or 0. So the outcome of this activation function there is a value between 1 and 0. And that gets applied to this node, and if there are any more layers to come, then this value gets passed on through the same mechanism through the neural network. So this is called, sorry, I went backwards. So this process of feeding the data from the input to the output, applying this formula, is called forward propagation. This activation function, one of the activation functions that we could use is something like softmax, which is just a statistical function. So this is called forward propagation. So the problem we have is that when we do this for the first time, we have no clue if this has worked. We have no clue if the value that we have here for our output node is in any way close to what the value should be. But when we're training, we know what the value should be. We have our data and we know what bucket it should sit in. So therefore we have an error rate. We know what the value should be, and we know what the value ended up being. So we can work out the error, we can work out the difference. And then what we do is we calculate the way in which that error rate will change if we change the values of the bias and the weights. And that's called determining the gradient. So we're working out the gradient of the error rate. And we apply that gradient back through to the bias, to the weights, and this is called back propagation. So we've gone through the neural network and we've tried to determine which bucket it's in. We've worked out how wrong we are, and then we go backwards through the neural network, working out, tweaking those values of bias and weights, and then trying again and seeing how close we get. And this process of backwards and forwards aims to reduce the error rate as much as possible. And once this training has happened, we then have a neural network which consists of the structure of the nodes and the layers, and then the values of these weights and biases. And that is what a trained network is. It is the values of the weights and biases on top of a neural network structure. Okay, so then once we now have a neural network, all of these connections now have weights and all of the nodes have biases. When we come to actually, we want to now put in a piece of data and have it come out the other end. Now, I'm talking about inputting stuff into neural network, but we have an image, and I'm just telling you about nodes. So what does that mean? How do you get from an image into the input layer of a neural network? Well, let's take an example like handwriting. So there's a well-used data set called the MNIST data set, which is full of examples of handwriting, hundreds of thousands of examples of handwriting of digits. And so we take one of these that we want to feed in through the neural network. So we have an image, and at the other end we want to get to, we want to put it in one of 10 buckets, 0 to 9. So we take one individual item, and we look at that in terms of the pixel values. So this is a 14 by 14 pixel image, very small image. We break that down into the pixels. As you can see, where there isn't anything in the pixel, it's 0. When there is a very, very dark indication in the pixel, that's 1. And everything else is somewhere in between. So that ends up with 196 values for those pixels. Now, the neural network doesn't actually care about sort of the x, y value of the core. It doesn't care about where the pixel is in the picture. It can just take 196 values between 0 and 1. And as long as every image that you put through the network is broken down the same way, it's not going to matter to the neural network. So what we end up here is an input layer with 196 values, and we feed in the pixel values from the image into the input layer, and that's how we bring the data into the neural network. Okay. How we do? So that's a very quick overview of how neural networks work and how machine learning works within the neural net, how you go about training a neural network to answer your question. Okay, so we want to add machine learning to our app. How do we go about it? What can we do? What are our options? So the easiest option is to use a machine learning driven API, a managed machine learning driven API. So something that does all of that hard work for us and gives us a nice RESTful API in front of it all, so we can just use that API, not to worry much about the management of the neural network. So you've got your app, some service is being provided in the cloud. We're going to interact with the API to train our neural network in some way. It might even be if it's a common class of problem that we don't even need to train it because the service is already providing us with a trained model. And then there will be another API once this network is trained to provide our data. It will use that trained network and it will just give you back the results. So there's a bunch of companies that provide these sorts of services like Google, IBM, and Microsoft. And that's great, but let's have a think about what sort of the advantages and disadvantages of this approach. So you don't need any machine learning knowledge to do this. It's a very simple API. If you can interact with a REST API, you can use these sorts of services. Really simple to implement. Often the service will provide an SDK for integrating with iOS and Android. It's light on resources because everything's happening in the cloud. Your mobile app is just making network connections, which is just normal, everyday, day-to-day things. But you're only going to be able to use it to solve problems that people have already thought of. So someone is going to have to have implemented this service, and it's going to have to be a service that is beneficial enough to enough people that is worth providing. So it's generally the common sort of machine learning problems, facial recognition, maybe natural language processing, that sort of stuff. You're introducing a third-party dependency, so if the service goes down or if the service terms and conditions change, that's going to affect you, it's going to affect your app. You're going to have to be connected to the internet to do all these things because everything's happening in the cloud. There's also data ownership issues, so if this is a facial recognition feature, then you're probably taking pictures of people's faces and uploading them to a third-party service that you don't necessarily control. You don't know what they're going to do with that data. So that's something you might need to make your customers aware of. And you have no control over the model improvement. So you're generating all this data from your users potentially, and the service can then use that data to make their model better, to improve their service. It's not really benefiting you. It might benefit you because the service will get better, but you're not improving your own IP. You're not sort of getting any added benefit from all that data you're collecting. Okay, so given that, I have an example of this sort of approach. So this is an app. That's a simple app that I built using, here we go, Microsoft Cognitive Services is one of these APIs I was talking about. They've got a bunch of different APIs for a bunch of different use cases, and they have one of them around facial recognition. So, we have an app here. Where's my Xcode? Just a quick look at sort of what's involved in the app. It's a pretty simple app. So I've added Project Oxford Face is the package that Microsoft provide. It's an SDK that helps you use this facial recognition stuff. There we go. So I can add that with CocoaPods, really easy to add, and I've got a face manager here which sort of handles the interaction with the API, and so you've got it basically takes there we go. So this is sort of what the interface looks like. I've got a bunch of model objects around the person, the face. The candidate person is the response that you get back from the service, and you add training image data. So I give it an image, and that's an image that's captured from the camera. Pass it to the Project Oxford Face SDK. It uploads it to the Microsoft Azure service, adds it to the training pool, trains the neural network, and then later on, when I'm ready to use it, I can pass it another image, and it will do the same thing, pass it through the neural network, and tell me what person it is. Let's do a quick demo of this. So the use case that we've got here is that, say we've got an app that's controlling our front door, okay, and we only want to unlock the front door when it's me coming home, when it can see my face from the camera. So imagine that my iPhone is mounted to my front door. This is how I'm going to enter my house, okay. So I've already trained my neural network earlier because it can take a little bit of time. So now we're going to try and unlock the front door using my face. But let's actually try it. First, let's try it failing. Let's see it not work. Let's see what happens when someone else comes up to the front door and it's not me. And let's see if it will unlock it. So I'm just going to grab my son. Hey there, buddy. Let's see if he can unlock the front door. Oh. Okay, so down in the bottom corner, the preview, you can see what the app is recognizing as a face. And to do that, I'm using the core image facial detection APIs. I'm just going to tap on the screen. It's going to take that, and you see in the top corner, there's a spinner to tell you that it's trying to determine whether it can unlock. And it didn't unlock because the padlock is still locked. Hey, buddy? Yeah, no, he's not getting in. However, I try and get in. Yay! Oh, didn't work. Brilliant. I wonder if it's my microphone. This is working like 10 minutes ago. Oh, damn it. Let's go back. So, I mean, one of the things this highlights actually maybe is that when I was training the neural network, I was outside, I was in different locations, and so the training data that I was feeding into the neural network was really, really specific. It was, let's see if we can, I'll try and retrain it. This might take too long, but we'll give it a go. So now if I'm feeding in training information which is more, so the lighting is going to be the same. Let's see. Yeah. It's because I've already pre-trained it. Let's give it one more go. If in doubt, delete it. Start again.
15 minutes.
15 minutes. Okay, cool. Now, I think we've got a bit of a networking problem actually, to be honest, because that should have prepared. Anyway, never mind. I've got another demo for you in a minute, so hopefully that one will go better. So, as we can see, like the neural network is only as good as the data you put into it. So you put data in a very specific scenario, very specific lighting. You go somewhere else, you try and feed data in, might not necessarily work. Okay, so that's so that was our machine learning driven API. That's one of our options. Another option. So we don't go down managed route. We have our own server. We implement our own neural network, and we host that somewhere. It's still remote. It's still not on the phone. It's still a server, but we manage it ourselves. We train it with data, perhaps from our AP, perhaps from our app, maybe from somewhere else, and then we take user data, or we take some data from the app, pass it into the machine, pass it into our server, and use that to then answer our question. And to do that, there are machine learning frameworks like TensorFlow and Torch, which provide a whole host of machine learning functionality and functions. And then for hosting, we have things like DigitalOcean or Amazon Web Services that enable you to get up and running pretty quickly. So this has its upsides and downsides too. So this time, we don't have to rely on just the common use cases. We can customize models to our needs. We can completely come up with our own machine learning model on our own, or we can make use of open source models that are available. So for things like facial recognition, there is FaceNet, which is an open source machine learning, an open source model for facial recognition. But we're still light on resources. We're still using the server to do all the heavy lifting. But this time, assuming that we're in control of the hosting, we're also in control of the data. We can decide on privacy policies and that sort of stuff. And as we gather more data, we can use that to improve our model, which is our own internal intellectual property. However, it sort of elevates the skill level needed in terms of machine learning knowledge and Python that's involved. You have to manage the server, so there's a certain amount of overhead involved in that. Plus, of course, we talked about the fact that we stick in machine learning tools on the server, but interacting with our app with the server, we're going to need some sort of API. So we're going to need to build that. Still need connectivity. Everything still happens on the server. So, is there anything else we can do? Well, there's this third option. We still do the model training on the server, but we actually use that model on the phone. So training the model is very takes a long time and is resource intensive, which is one of the reasons why we do it on the server. So we can still have our own server. We can still use our server to train our data, to train our model. That could be data from the app, or it could be data from somewhere else. And we have same sort of resources available there, TensorFlow, Torch, and we can host it. But now, rather than using the model on the server as well, we want to take the model and bring it onto the phone, our trained model, and host it on the phone. And now we're going to actually use the model on the phone to do our asking our questions. So here's a face, is this person? We do all that on the phone. And to do that, there's a few ways we can do it. We've got mobile versions of these machine learning frameworks. We've got TensorFlow and Torch, both can be installed on the phone. And so then what we need to do is we need to take the trained model we talked about earlier, those weights and biases that we've generated. We need to take them, bring them onto the phone, and then use them on the phone with the same frameworks to answer our questions. As of iOS 10, we also have some machine learning APIs built into iOS. So the Accelerate framework has a bunch of APIs for creating machine learning, for creating neural network structures. And that uses it's highly optimized, but that uses the CPU. And then the Metal framework, used for game programming, also has some neural network APIs to take advantage of the GPU. GPU is always always going to be really, really good at doing neural network stuff. Just so happens that the processes for manipulating graphical information, vector transformations is often what's happening. That is also very good for neural networks. It just happens to be that GPUs are highly optimized to do this stuff. Okay, so that gives us some trade-offs. So now we still customize the model to our own needs. We can make use of open source models. Now the difference now is that all the work is happening on the phone. So in actual fact, we can put the user in control of their own data. Perhaps we don't even need to see the data that is being used to answer this question. And that can have, that is going to benefit the user. It might not benefit us because it might have some implications on whether we can improve our model, but it'd be great for the user. It can work offline too. There's no networking needed. Once we've downloaded the trained network, which is just a one-time deal, which can be done in an app launch or whatever, or it can even ship with the app, then you can work completely offline. Again, you still need quite a lot of knowledge in terms of machine learning tools. There's still the server management for the training of the model, but actually that's just a one-off deal, really. And you need to be able to transfer this complex model to the phone. So, and how you decide to do that, I've got an example in a minute, but that has its own issues. And like I said earlier, it may limit the scope of improving the model because you might not choose to actually give that user data to your server. You might decide to keep it local to the phone. So the demo gods might not be on my side, but let's see if I can. So, right. What we have here, and I've already got it running, is Amazon provide these AMIs, this sort of pre-built servers that you can just spin up with just a few clicks. Really cool. And this is one from Amazon on deep learning. It has TensorFlow installed by default and Torch, a bunch of other things. I think Cafe is installed by default. And you can choose sort of what size of instance you want to spin up. You can spin up like a really small one, it won't cost you much. Or you can spin up a really beefy server to sort of plow through a lot of data. And actually this is one instance where the beefy servers actually might pay for themselves because I'm about to show you an example using the MNIST handwriting recognition data set. And I was trying to train the model using a medium-sized Amazon server and it took 4 hours, about 4 hours, and then I decided to whack it on a really beefy server, so I think this one, the M410 Lite, something like that, and it took under an hour. So if the beefy server is less than 4 times the price of the cheap server, then actually it might end up paying for itself by choosing a really beefy server. So I've actually already got one running. I'm going to try and connect to it. Okay, anyway, so I've connected to the Amazon EC2 instance that we've got running here. On here is a Python script. I'll show you the Python script. This will be available to. I'm going to put this on a repo that's linked at the end of the show notes, at the end of the presentation notes. So what we have here is a Python script that sets up this neural network to use these handwriting recognition examples. So here we're downloading the handwriting recognition data, and it's actually provided by TensorFlow. They've got a really nice, easy way of importing the data. Here we're setting up the structure of the neural network. So we're setting up those layers that we see, that we saw earlier, and we're connecting them such that the information is going to pass from the input through the hidden layers to the output. This is our softmax activation function. There. So in TensorFlow, everything's done using a session. So we start the session, and this is the bit that loops through and creates and runs that process of training the neural network using our input data. And then at the end, we take our trained model now. So now we've got all of our layers, we've been through the training process, and all of our layers and nodes now have the weights and biases that are the trained network. And we want to export them so that we can then bring them over to the iOS app and use them. So that's what this does. There's a slight wrinkle in that the way that TensorFlow represents these weights is different from the way that the metal framework, which we're going to use in a second, expects the weights to see. So there's a bit of transposition that's needed. I got this stuff from a blog post, which I'll put into these comments. It's really useful. And then, so it goes through all that process, trains the model, and then kicks out these values for the weights and biases. And that's what we're going to need to then provide to our app. And so that's all in a Python script. Where's my terminal? So, and kicking off a Python script is as simple as Python. That's going to take, like I say, just under an hour. So we're not going to wait around for that. So let's go to the one I prepared here. So now we're going to need to provide, we'll need to have provided an API or a way of taking that trained data, pulling it off of our server, providing it to our app. Now, let's have a look at this example app that uses that data. So this is actually an example provided by Apple for using these metal framework machine learning APIs. Okay. As I said, this is using handwriting recognition, so use our deep neural network. So we're going to write a digit, detect digit, and through the neural network, put it in a bucket, decided which of the 10 buckets, 0 to 9, was the one that had the most value. What was the highest number for all of these buckets? Decided it was in the 2 bucket, and so then it tells you it's a 2. So let's try another digit. 5, 7. That's because I did the international 7. 7, 8. Doing pretty good. 0. There we go.
Can you make hole in the middle?
Could I make a call?
Hole. Not exactly covered, but...
Oh, that's what you mean, like kind of like that?
Yeah, uh-huh.
There you go. Let's try
Inside.
5. That's 9. It's doing pretty good.
Could you write an ampersand?
So it's only trained on... No, see. Yeah, it's only trained on 0 to 9 digits. And so actually part of this is worth talking about. Part of actually making this machine learning stuff useful is understanding how to break down the problem into bits that machine learning can solve. Okay, so you've got, say you're building a program that is like a calculator, and you want to be able to input your calculation by drawing on the screen. Now, to use this neural network, you need to provide those digits. It's very good at recognizing the digits, but the digits are only individually. So there's sort of a multi-step process that we've got to use in order to make this stuff useful. So we've got a big string of, or we've got a big canvas of text that someone has written. We're going to need to do some analysis to break those down into individual digits. And only once we've broken them down into individual digits and sort of crop them so that they're all the right size, can we feed them into the machine learning algorithm to get this answer, and then put them all back together to understand, okay, what they want was 765437. You know.
Can you rotate? Can you show result?
Oh, if I do this like that, is that what you mean?
Mm-hmm.
There you go.
More.
Well, like this. I don't know. You go far enough and you get 6. So, well, actually, on that point, let me show you. So, those are the sorts of questions that you're going to need to solve. But machine learning doesn't solve everything, and it needs to be given the right information. So, we're talking about thing being rotated. Oh, why don't we do it? Because it's failed to prepare. That's so annoying. Damn it. Hang on a sec. So I'll just talk about it. So part of the image that I had there for this talk angle, yeah, face it. Yeah, okay. So in processing the image, I was talking about I used the face detection features that are in core image to extract out just the face from the whole video capture of everything, the scenery, everything around me. And actually, that also probably uses a neural network underneath to do that face extraction. And one of the things that the core image framework gives back to you is the angle at which the face was orientated. And so then I use another core image filter to rotate it back to normal. So there's a certain amount of data normalization that you want to do in order to try and help your neural network do as good as it can do. You want to give it consistent data. So if you can do anything to crop all of the images so that everything's in the center, whether it be digits or faces, rotate the face so that they're all sort of, straight up. All of that stuff is going to help your neural network work better. How are we doing for time?
5 minutes.
Brilliant. Okay.
Maybe if we add some more examples like for training and adding more buckets at the 0 to 9, right? But if you add some more, like rotated 6 on a 90 degrees, and so on. So we will know at the end that this is a 9, but it's rotated. And then
The
we
problem
can
with
do
the-
this, conversion at the end.
Yeah, the problem you have with that is that the problem you have with that is, for a start, there are 360 possible angles that it could be at, and that actually, it might be that is the way to approach that problem, but it might also be that if this feature is in an app where you're writing, so it's handwriting recognition. Let's forget about the digits and say it's actually like, I don't know how many characters are in the Cyrillic alphabet, but for like the Latin alphabet, you've got like 26 different characters that could possibly be, 26 different buckets, right? And you're doing handwriting. It might well be that actually the simpler way to solve that problem is that if the person is writing, everything is going to be at the same angle. So it's going to be quite easy to determine the angle that they're writing at. And then you can just use some image transformations to straighten that up, and then cut out the individual letters and send that through a neural network. You know what I mean? That might be the easier way to solve it. That might be an answer as well, but I feel like there's probably easier ways to solve it. And the more buckets you have, I mean, and certainly there are machine learning problems that have a very, very large number of outputs buckets. The smaller amount of buckets you have, generally the easier it's going to be to train your network. So just to wrap up, really. So those are our three sort of general options for adding machine learning. Feature, we've got using an API, doing everything on the server, but it being our server, or doing the training on the server, bringing the model over to the phone, and then actually using it on the phone. And then just briefly, so hopefully these are some of the things that might help us in the future. Things like easier ways to transfer the model from the server to the phone, maybe a standardization of neural network model formats. Yeah, so if at the moment these APIs from Apple that we got as part of iOS 10 are only good for using a neural network, that you can create a neural network and you can put stuff through the neural network. They don't have the facility for back propagation. So you can't actually train your neural network on your phone. And that was clearly a very deliberate thing from Apple, because they knew that people would be training these models on be doing it on the phone. But it would be nice to have those APIs. We could have an Apple server somewhere, just to do the training. It would be nice to get them. I kind of feel that Apple probably have a whole machine learning infrastructure. They're like their own version of TensorFlow, and they just released a small subset of it. So it'd be nice if they were opening it up more. The ability to plug and play, sort of, maybe an easier way of connecting up neural networking models, again, maybe some standardization around how these models can talk to each other. And there's a bunch of tools for machine learning in Swift, a bunch of frameworks for this sort of stuff. Really early days, so nothing that's really production ready yet, but it'd be great to see more machine learning stuff in Swift natively. Now, I've got a bunch of links at the end of this. This is so that when you get the slides, you can have a look at all these resources. There's stuff on different machine learning APIs, some open source models, some of the machine learning frameworks, some places you can host it, including the AMI that I've used. And yeah, some stuff on iOS, some links to the Nettle framework example code that I used that's provided by Apple. And then the first entry example, which does work, I promise you, is available on my GitHub. And so Justy has some open source iOS tools as well, some of which I've written. Okay, so it's been a mess. So yes, we've had a few questions as we go on, but are there any more questions?